Our next video is about altitudes and perpendicular bisectors. So what are the similarities and differences between medians, which we learned about in the last lesson, altitudes, and perpendicular bisectors? Some new vocabulary terms are altitude and perpendicular bisector. In geometry, an altitude of a triangle is a perpendicular segment with one endpoint at a vertex and the other endpoint on the side opposite that vertex. The altitude AD is perpendicular to side BC, and I know that it is perpendicular because I see the right angle mark. Please note that the altitude is not bisecting segment BC, it is just creating a 90-degree angle. An altitude of a triangle may not always lie inside the triangle. Altitudes of triangles depend on what type of triangle they are. So in an acute triangle, the altitude is always inside of the triangle. In a right triangle, an altitude is either of the sides. And in an obtuse triangle, the altitude is outside of the triangle. The orthocenter is the point where the altitudes intersect. So in this case, point P is the orthocenter. The orthocenter is different than the centroid, which we learned about in the last video. If a point is labeled an orthocenter, all the lines that are concurrent are therefore altitudes. Another special line in a triangle is a perpendicular bisector. Well, a perpendicular bisector is exactly what it claims to be. A perpendicular line or segment that bisects the side of a triangle is called a perpendicular bisector. Therefore, line M is the perpendicular bisector of side BC, and I know that segment BD is congruent to segment DC. Please note that the perpendicular bisector does not have to originate at a vertex. If a line originates at a vertex and creates a right angle, that is the altitude. These lines are not always the same thing. The perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So what this is saying is, I have line CD is a perpendicular bisector of AB. I know if I connect the points CA and CB that this now becomes an isosceles triangle. That is all this is saying. If this line is perpendicular from the vertex and the sides are bisected, I know that this is an isosceles triangle. That is all the perpendicular bisector theorem is saying. The converse of the perpendicular bisector theorem is the opposite. I know that if AE and EB are congruent, then this is an isosceles triangle, and I know that a line that comes from the vertex down and intersects the other side, that it will bisect it and create a right angle. So this line, EC, is an altitude and a perpendicular bisector. These are converses. If this is a right angle and this is bisected, then it is an isosceles triangle. The converse states, if it is an isosceles triangle, then the line from the vertex opposite creates two congruent segments and one right angle. We can use the perpendicular bisector theorem to find a missing side. So the perpendicular bisector theorem tells us that AD is congruent to DB, and this is a right angle, which means that this is an isosceles triangle, so BC is 8.5. If I want to find XY, well, this is the converse of the perpendicular bisector theorem. Triangle XWZ is an isosceles triangle, and this angle is a 90-degree angle. Therefore, ZX is bisected, and Y is the midpoint. So if YZ is 6, XY is 6. If we want to find PQ, PR is bisected at point S, and there is a right angle at angle QSP. Therefore, I know that PQ and RQ are congruent sides. This is an isosceles triangle, so all I would have to do is set the segments equal to each other and then solve. So 3x plus 1 is equal to 5x minus 3. I subtract 3x from each side, and then I add 3 to each side, and then I divide, and I know that x is equal to 2. But the answer asked me to find PQ. It doesn't ask me to find X. So I need to substitute back in, and I get that PQ is equal to 7. Here is an example for you to try. I know that the answer is 9.2 because this is a 90-degree angle, therefore it's a perpendicular bisector and an altitude. I know it's a bisector because LM is congruent to MN, which means that this is an isosceles triangle, and therefore the answer is 9.2. The answer is 4 because since this is an isosceles triangle and this is a right angle at angle WUT, I know that segment VT is bisected, therefore if one side is 4, the other side is 4. I know that the answer is 20. Since this is an isosceles triangle, since this segment is bisected and there's a 90-degree angle, I would take 5x minus 20 and set it equal to 3x minus 4. I subtract 3x, I get 2x. I add 20 to each side and I get 16. Therefore, x is equal to 8. And since I want segment EH, I would substitute x into there. And 5 times 8 is 40 minus 20. Therefore, my answer is D, or 20. The circumcenter theorem. The perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So right now we have learned about the circumcenter, the orthocenter, and the centroid. Please note that the circumcenter is equidistant from the vertices. So that means BP, AP, and CP are all congruent. That marks the end of this section.